All right, let's do an example. So this is a word problem, so I'm going to read it and then write out the information. So again, I would write out the information as well, and so that way you have it in your notes. So it says here, suppose $15,000 is invested, and at the end of 3 years, the value of the account is $19,356.92. Use the model A equals P times E raised to the RT power, so there's our continuous compounding formula, to determine the average rate of return under R under continuous compounding. Okay, so that's a given. Okay, so now, so what we want to do is write down the information. So it says, first of all, suppose that $15,000 is invested, and at the end of 3 years, the value of the account is $19,356.92. So P, right, the principal amount deposited, that's going to be our $15,000. Okay. A, which is the future value, right? So this is after the 3 years. Is the what? $19,356, right? $19,356.92. And then, of course, T is the 3 years, right? And so the only thing we don't know that we're not given is R, which is what they want us to solve for. So if we use our formula, A equals P times E to the RT, okay, let's fill in our values. So it's going to be $19,356.92 is equal to 15,000 times E to the R times T, which is 3, so I'm just going to put 3R as the exponent. Okay, and now we're going to solve this like we did in the last example we did about solving for a specified variable. So that's what that was all about, right? So that's what we're going to do. So the first thing I'm going to do is divide both sides by 15,000. So this will become $19,356.92 divided by 15,000. And then I get E to the 3R. And now I'm going to take the natural log of both sides, right, to get rid of this E and get the exponent out. So now I'm going to take the natural log of the ratio $19,356.92 divided by 15,000. So now I've got that natural log, and of course I take the natural log of this side, E to the 3R. And of course the natural log is going to cancel with the exponential since they have the same base. Or you could use the property of you can use the other property that pulls out the property of logs, that pulls out the exponent, and then use the fact that the natural log of E is 1, right? So either way, you get the same answer. So you can use different properties to get to the same results, right? So whichever one you are comfortable with, whichever one you notice right away, that's fine. So the end result is going to be this, right? We end up with the natural log of $19,356.92 divided by 15,000, right? So we get natural log, and over here we just get 3R, right? And so what do we do? We divide both sides by 3, and we're done, right? So this is what we get for R, right? And so again, we want the average rate of change under continuous compounding. And so let's see what we get when we put this in the calculator. All right, here we go. Okay, so let's do this. Okay, we're going to take the natural log. Okay, so 19,356.92 divided by 14,000. And we're going to divide that by 3. And we get 0.084999. So 0.084999. Okay? So that we get approximately 0.084999. So we could say approximately, if we round to the nearest 0.1%, this would be equal to approximately 8.5% as the average rate. All right, that's it.